All right, so after we do pictographs, which are generally quite simplistic, let's add a little bit of complexity into this one. So we're going to look at contingency tables and then follow that up with segmented bar graphs because they kind of go hand in hand. So we've learned some techniques for analyzing the distribution of a single categorical variable. If a data set involves two category variables, we use something called a two-way table. A two-way table is just a contingency table. A two-way table of counts organizes data into two categorical variables measured from the same set of the individuals. So let's look at the example that we have here. Only 32% of those aboard the Titanic survived. Was the survival rate the same for all the ticket classes? To answer this question, we can arrange the counts of the two categorical variables, survival and ticket class, in a two-way table. So we see a couple organizations here. First, we have our classes organized between first, second, and third class, followed by the people that worked on the Titanic, the crew. We also want to look at if they were alive or dead after the Titanic crashed. So in this case, survival is our row variable, whether or not they survived. We'll make that red. And our column variable is class, which is shown up here. The margins of the tables give our totals. So we've seen the margins here, the total first class, second, third, and crew, how many total are on it, how many people are alive, and how many people died. They should all add up to 2,201, whether alive and dead, or first, second, third, and crew are being summed. So when analyzing a contingency table, the goal is to see if the variables depend on each other. This can be done by looking at the two possibilities. So we look at our conditional distributions. That's looking at our rows and our columns. If we think that class might depend on survival, then we should look at the distribution of the row percentages. So if we think class might depend survival, then we're going to look at the rows percentages. So I'm going to take the percentage of each of these. This 203, my 120 or 122. Make sure I'm totaling up all these values. That my alives and my deads still sum to give it all together. This is the conditional distribution for class based on survival. So class based on survival will be these percentages here. However, in this scenario, it might make more sense for us to determine if the survival actually depends on the class. To do this, we would look at the column percentages. This is a conditional distribution for survival based on the class. So here we have, did they survive based on their class? If we take a minute to look at this for a little bit, we see that the number of people in first class that survived, out of that 325, 62.5% survived. Out of the third class, only 25% of them survived. The crew, only 24% of them survived. In total, 67% of people died, which is the same as the first class survival rate, which I think is pretty crazy. So we're going to say that it sure seems that class influenced whether a person survived or not, because we see that 62.5% of first class passengers survived, while only 25.2% of third class passengers survived. Two-way tables are often displayed using segmented bar graphs. So those tables that we're just looking at can be then shown as a segmented bar graph. So here we see two bar graphs. The first one is our row, the second one is our column percentages, using our frequencies followed by our conditional percentages. We can see the dead and the alive based on the class. So these blue portions up here, followed by the red for the dead as percentages and as our frequencies shown in relative. If we take a look at each of these, the cool thing about them is if we tally up these numbers right here, it should be 322, which relates back to our 325. When we tally up all these pieces, they would match, they would match, they would match. The thing that I like when we put it in percentages is they all total up to 100%, which I think shows a pretty accurate description of the question that we're being asked. Did class determine your survival percentage? So let's look at it. Survival percentages means, do you have a chance of living? If you're in first class, you have this high of a percent chance of winning. If you're in third class, you only have this high of a percent chance of winning. That is a very clear visual representation that, yeah, class had a good determining factor whether or not you survived. One note to say is that the bars of each graph have the same proportions, but it's easier to see in the second graph that the first class passengers had the highest proportion of survivors. So yes, this one's still the highest, but it's a little bit difficult to see right here. Actually, the crew looks like it was a higher actual number, but there's so many more crew members that when you look at them in comparison or proportional to each other, that this is a much clearer representation of that. I don't find the segmented bar graphs a difficult part of that. I find it's normally the contingency tables, called our two-way tables, that take a little bit to wrap your mind around when you're reading them. Take it slow, look at your columns and your rows, and see what you're finding when you work with them.